So many of you will end up being a designer. Okay, so you should know what is a good design. Okay, so let us start from here. Let us make it. Okay, let me ask you, of these two, which is the better design? What is there towards the left of you? Can you see that? What car is that?
Jaguar.
Yeah, it is a Jaguar car. And what are you seeing towards your right?
Nano, sir.
Nano.
Yeah, it's a Tata Nano. So according to you, which is the good design? So we have.
Economy is control.
Sorry.
Economy.
Sorry.
Sorry, economically, Nano is better.
Yes, it's a very carefully thought answer. Very good. Who said that?
Sir, Vignesh.
Vignesh. Very good. Very good. Any other answers? Or rather, I should say, any other points to be added? Any other thoughtful? Any other thoughts? Come on, guys. These things you all would have came across millions of times. So these things you are well aware of. Which is a better design, according to you? I won't judge you. Please come up with answers. See, the only thing that you can do to stay in subject is just to interact. Okay, you can interact as much as possible. Tappo righto. Answer solano. Okay, so only then you will be in the class and I can be in the class. Okay, so just listening to the lecture won't help you anything. Okay, so try to be as interactive as possible to make the class better.
Sir, safety
I
padi
think-
pata Jaguar konjam better agu sir.
Is it?
Safety.
Okay, safety wise Jaguar is better. So
Sir, I think both the cars have very good design, sir. When
Okay.
considering luxury point of view, Jaguar is good, and as
Okay.
Vignesh said, in economical point of view, Nano is good, sir.
very good. I was hearing someone from girls' side. Someone was trying to say something. Please proceed. Any other answers? Okay, so you guys were outstanding. So normally people will say that Jaguar design is better, but you guys are clear about what you are saying. So design is not only about the aesthetic appearance. That is my first point. Okay, so design, a good design may not be seen from the outset. Okay, it can be inside. It can be the cost factor. It can be the safety factor. Okay, it can be the performance factor. Right? So there are many other factors that drives the good design. Okay, so aesthetic appearance is one such that. Okay, it is one of the factors, not the only factor. Okay, so as a designer, you should ensure all the factors to be better. To be frank, you cannot compare these two because Jaguar is something having a different design objective. It costs around 47 lakhs, whereas Tata Nano just cost around 2 lakhs. Okay, so if you think of it's just around 5% of the Jaguar cost. Okay, it is very much cheaper. Okay, so you cannot compare the cost implications of both. Okay, so whereas that Jaguar is around 2000 cc and Tata Nano is around 700 cc. So these are the performance factors. So there's a huge difference in the design objectives. So frankly, you cannot compare both. But just for the sake of design, so to drive the points in the design, I just compare these two. Okay. So the first thing you should understand is design is not only about the aesthetic appearance. So there are a lot of factors driving in it. So a good design should use of scientific principles and the technical informations and the imagination. Okay, so you should apply a lot of scientific principles to your design. So that scientific principles will come from strength of materials and engineering mechanics. So the scientific principles that there you have learned, you should apply here. Okay, in the description of a machine or machine system to perform to the maximum economy and efficiency. So these are the driven points behind the machine design. Okay, so these are some of the common questions. What is the machine design? So it uses scientific principles and it uses technical informations. So technical informations can be many. Okay, what are the materials available? What are the manufacturing process? So these are some of the technical information that you should understand. Okay, and you have to apply your imagination in describing a machine or a machine system to perform to the maximum efficiency and maximum economy. Okay, so you should optimize the cost. So these are some of the implications of machine design. So there are types of designs. Okay, so one thing is we can call it adaptive design, development design, and new design. New design is something also we can call it as innovative design. Okay, so do you see what is here? So this is some example for innovative design, new design. What you are seeing up front of you. Can you recognize that? Do you guys recognize this? What is this?
The 3D printing is not.
Perfect. So this is the first 3D printer that was ever made. Okay. So do you know when it was made? Any idea? The concept was generalized in 1980s, and it was, I think it came to the market in 1990s. Okay. The first, the company that marketed the 3D printer was Stratasys. Okay. So Stratasys first get into the market in 1990s, but later only in 2000 and 2001 this printer have got popularized. Okay, it's because of that patent implications. Okay, so during that 1990s and 2000 the 10 year in between, the patent was intact. Okay, only Stratasys can make use of the patent, and after 2000 the patent got expired. Okay, so only when the patent got expired and other companies came into the foray. Okay, so there were many companies now. There are around thousands of companies, I should say, that is into the 3D printing department. So the first design that was ever made, that is innovative. Okay, so the innovative design needs a lot of research and it has the technical ability and creative thinking. Okay, so this is where we are lagging off. Okay, so there are US, Germans, and even down the Chinese are pioneer in innovative designs, but we as Indians are very much behind them. Okay, we are not into innovative designs. We are only into the development and adaptive designs. Okay, so the development and adaptive design is something different. So I will come to that later point of time. So the new design. So new design is something very innovative. So it should be the first of its kind. Okay, so it needs higher order for taking up the work of new design. Okay, so it should be like out of the box thinking. Okay, it should come from nowhere. Okay, இது முன்னாடி பண்ணாம first time market la irukkiradhu அப்படிங்கிறது தான் innovative design. Okay, so as I said, so we have to catch up a lot in doing innovative designs. Okay, but we are in development designs, so it needs considerable training, and it has to modify existing design to new idea by adapting new material or different method to manufacture. Okay, so 3D printing I can take as a best example, because the first 3D printer makes use of resin by use of UV lights. Okay, so UV light pass பண்ணும்போது the material will get solidified and you will be getting the required object. Okay, so by now you should be well aware of what 3D printing is. Okay, 3D printing is layer by layer manufacture as compared to conventional machining. Conventional machining என்ன பண்ணுவோம், there will be a mass of raw material where you will be doing the cutting, and so you will be doing the machining process mainly. Okay, so you will be removing the materials off and you will be getting the required shape by removing the material, whereas 3D printing is something we will be adding the material layer by layer. Okay, so that is the concept behind these two. So initially it was made use of resins, and now it makes use of filaments, and it makes use of metal powders, and also it makes use of ceramics, and now the materials are endless. Okay, now you can use any type of material for making a 3D printing substance. Okay, so this is what we call development design. Okay, initially it was just made for resin, now it is made for metals, now it also been made for ceramics. So likewise the materials are endless. Okay, so these are called development design. Okay, so the final product should differ from the original product. Of course it differs, because you cannot use a metal powder as similar to the polymer resin. You cannot use a ceramic powder as similar to the metallic powder. Okay, so each material needs a specific temperature, a specific manufacturing process. Okay, so it will differ from the original product. Okay, so these are what we call a development design. And there is something called adaptive design. This is what, and this is where we are best at. So what, as Indian engineers, what we'll do is we will have the existing design, and it will be do the adaptation for our Indian conditions. Okay, for example, in US, the car engine has to be made for the minus 20 degrees Celsius. Okay, ஒரு சமயம் பார்த்தா minus 20 degrees Celsius இருக்கும், ஒரு சமயம் பார்த்தீங்கன்னா 40 degrees Celsius போகும். So temperature difference is around 60 degrees Celsius. Whereas in India, mainly temperature will be between 15 to 50 degrees Celsius. Temperature difference ரொம்ப கம்மி. So இதுக்கு நம்ம டிசைன் அடாப்ட் பண்ணா போதும். So அந்த அளவுக்கு கூல் கண்டிஷன் அடாப்ட் பண்ணணும்னு அவசியம் கிடையாது. ஓகேவா? So what we can do is we can make our engine just to withstand this temperature difference. Okay, so ரொம்ப வந்துட்டு sub-0 degrees Celsius நம்ம போகணும்னு அவசியம் கிடையாது. So we can adapt our design for our requirements. So in that way we can do the cost cutting measures. Okay, so this is what we call adaptive design. So, okay, this is what we are doing in India. So it needs no special knowledge or skill. Okay, so already we are going to do some minor changes. So it can be done with ordinary technical training. Okay, so it is the it is not that difficult. Okay, so it forms the it is the least difficult design. Okay, adaptive design is something very much forms the base of it, and you have to build over it. Like adaptive design is very simple, and development design is much more complicated, and innovative design is very complicated. Okay, so this is adaptive design, and this is manufactured by I think it is called Voxel. Okay, VOXEL. So these are a kind of startup companies. Okay, so there are many startup companies now these days that are doing 3D printing manufacturers. Okay, so these companies came from nowhere. So after the patent got elapsed, so many startup companies have taken the 3D printing manufacturing. Okay, so this needs no technical training, no special knowledge or skill, just adapting a concept behind the existing design. So this is very simple. Okay, this is I already said. So it needs minor modification to the existing design of the product. So there are other designs as well. Okay, so those design in general are classified into three. So the innovative design, development design, and then adaptive design. Okay, so those are design developments. So in other ways we can classify the designs. So these are rational design. The rational design is something, a thoughtful design. Okay, you should think to make a particular design is what we call rational design. Empirical design. So do you have any idea about empirical design? Any examples? Empirical design is just following up the procedure. Okay, so you need not apply concepts. You all need to do is follow the procedures. Any idea for empirical design? Any answers? You can explain these things actually. Empirical. Any examples? You can take the example of gears. Okay, so the gear concept was made many hundred years ago. Okay, so now you know how well the design has been made now. Okay, so these are just following up the footsteps of the previous designs. So there are standard procedure for making a gears. Okay, there are some standard instructions and procedures. Okay, so those are well given in design data book. Okay, so I have to introduce this. So this is design data book. You would have already used this while doing the concept of engineering design. And again, this forms the main part in design of machine elements and design of transmission systems. Okay, so you will be making use of this. And if you don't have one, please buy one. Okay, so this book you will be using for life. Okay, so it will be needed then and there, even after going to industry. Okay, so it's better to have one with you. So the procedure is well elaborated in this book for making a gear design. Okay, so that which doesn't need much of a thought and just following up a procedure is what they call empirical design. So empirical design just makes use of a calculation and procedures. Okay, that is what empirical design is. Okay, and what do you mean by industrial design? What is industrial design? Any idea? So industry design deals with basically the quality and what else? The Six Sigma. You have studied about Six Sigma, right? So those things deal about the quality and basically the production area. So where you have to cut off the lead time and where you should reduce the number of employers and you should automate the things. So those things are dealt well with industrial design. Okay, so basically it deals with the quality and quantity of the productions. Okay, and what is optimum design? So whatever you designing, you should design with optimum cost and material, right? So you should not waste the resources. So making use of the optimum resources for making a particular design is optimum design. And what is system design? So normally, as we are seeing in this particular subject, you will not be you will not be designing a particular element. So element is part of a system, right? So designing a particular system or complete system is what they call system design. Okay, so the system is endless. So a collective design is a system design. Okay, and finally the element design. So these are sub parts of the system design. Okay, you have to design the individual components to make a part of the system. Okay, so these are some of the design topics. Computer design. So making use of a computer to model or design something is what we call computer-aided design. So these are the other design classifications. So next thing is the procedure of machine design. Okay, so if we have to design a particular machine, for example, say a lathe or a car or even a bicycle, how we can make a design procedure out of that? Okay, say you are going to start a startup. So startup ஆரம்பிக்க போறீங்க for say a cycle production, just to bicycle produce பண்ணணும். Okay, so how will you arrive at the design procedure? Where will you start? பார்க்கலாம். Where will you start the design?
Sir, frame of the cycle.
Frame of the cycle. Okay, so I should say it is a third or fourth step. So before that, you should follow a few protocols. What are those?
Sir, designing according to our requirements.
Okay, that's a very good answer. That forms the second step. So we have to arrive at our requirements, right? But requirements arrive பண்றதுக்கு என்ன பண்ணணும்?
Sir, basic.
Sorry?
Sir, we have
Basic
to
requirements.
the previously existing types of bicycles, sir.
Right. So requirements இருக்குங்கிறத எப்படி தெரிஞ்சுப்பீங்க?
Market research.
Exactly. So market research or market survey forms the first step. Okay, that's very good. So market survey. So first you should read the pulse of the market. உண்மையிலுமே இதுக்கு need இருக்கா? Or already what are the existing products that is available? What are the competitors for us? Right? So how well we gonna differ from them? Okay, are we going to differ by the means of performance or by the means of cost? So that's the second step actually. So market survey panningana da we can arrive at the design specifications. Okay, so we have to define the specification of the product. Okay, so if we are making a design, are we going to design a geared cycle? Are we going to design a cost-effective cycle? Or we going to design a weightless, a feather-like cycle? For example, there are many trekkers around the world, right? So normally you can see that many trekkers will be carrying the bicycle like a bag behind them. Okay, they will just bicycle என்ன பண்ணுவாங்க, they will just fold it off and will just carry through to the mountains. Okay, so those are like weightless cycles. It will be just weighting around like 15 kg I mean 10 to 15 kgs, not more than that. Okay, so those things are made of carbon fiber. Okay, so that's why you can say that is of less weight. So those are the design specifications that you have to arrive at before doing our main design. So after that, we have to study the alternate mechanisms. So someone said the frame of the cycle. Okay, so mechanisms. So only after the specification of the product, you can go to the mechanisms. Okay, so what are the mechanisms that we're gonna use? What are the materials that we're gonna use? So those are the mechanisms. Okay, mechanisms in the sense that the gears use பண்றோமா இல்லையா? So those are coming under mechanisms, right? So that forms the third step. So first you should study the alternate mechanisms and we have to pick one. That is the fourth step. Okay, with the choice of mechanism is very important in the design procedure. Okay, because only mechanism forms the heart of the design and the other parts will be shuffling around them. Okay, so the mechanism forms the core of the design. So you should be very selective and you should be very knowledgeable in studying the mechanisms. And after studying the mechanism, you should form general layout. So what are the supportive things for a particular mechanism that we have chosen? For example, if we have chosen the geared bicycle, so how well we are going to transmit the force to the pedals and how well we are gonna transmit, what are the chain that we're gonna use, how many links should be there, and what are the precautions that we taken to fold the cycle. Okay, so these are some of the mechanism thinking that you have to go through. So after going through those, we have to form the general layout. So how we can fold that? What is the layout that we need for that? Okay, so these are the plannings that take place before doing the mission design. And the very important thing is we have to choose the joining methods. Okay, so are we gonna do the temporary joints, or are we gonna do the permanent joints? So those are the questions that you have to answer while doing the mission design. Okay, so do you have any idea about that? What are temporary joints and what are permanent joints?
Sir,
Any idea?
temporary joints வந்து bolt nut use பண்ணி பண்றது.
Exactly. So
Permanent joint welding.
perfect. So these are the best examples. Okay, we will be studying these in detail. So the riveting, welding will be the permanent joints, whereas the bolts, nuts, and adhesives, okay, the glues, those are coming under temporary joints. Okay, so are we going to bolt them, or are we going to bolt them, or are we going to weld them? So these are the main questions that we will be going through while designing a particular system. Okay, and after this we have to design the individual components. Okay, so we have to select the, we have to design the gears, we have to design the chains, we have to design the frames, we have to design the bearings. Okay, so we have to design the individual components step by step. Okay, and for the individual components, you will be following a certain procedure. So that is different. So machine design is something you're designing a particular system. You're not designing a component. Okay, so after this you have to design the individual components, right? So someone is having fun, right? So after designing individual components, we have to prepare assembly and detail drawings, right? So here where the CAD part is coming actually. So we have to design the drawings. We have to do the drawings. So already would have studied the SolidWorks software, right? So you should make use of the softwares to make use of detailed drawings and assembly. And finally, we have to do the prototype. Okay, so for doing the prototype, which is the best procedure? Which is the best manufacturing process that we have seen just now? How we can make the prototype?
3D.
Yes, for testing the prototype, you can make use of additive manufacturing or 3D printing. Okay, and after testing the prototype, if the results are not satisfactory, or if you want any improvements in our design, then we can modify our drawings based out of the performance that we have seen in that prototype. Okay, so these are the design procedures that we have to carry through while designing a system. Okay, so in next class we can see about the design of individual components. Okay, so this forms a separate procedure. Okay, so this procedure we can see in the next class.